All right, we're going to talk about quadratic scatter plots. And quadratic scatter plots are really not that different from linear scatter plots. I mean, obviously, except that they're quadratic instead of linear. But in terms of how we deal with them in the calculator, they're not that different. But we're going to start by looking, instead of looking at using, stat calc to figure it out, we're going to actually look at graphs, because you are also expected to be able to just make changes to a graph and understand how to change them. And we kind of did that on the assessment that we just took, where we're talking about making changes in A, H, and K. We're going to kind of be thinking about that same thing as we look at quadratic data. So we're going to start with this one. It's about a book under a motion detector. All right. We're going to start by putting this data into our calculator. Remember, we go to Stat, Edit, and then we look. Hold on. Kind of make my brightness. Oh, let me make the brightness lower. There we go. That's going to make it a little easier to see. Okay, so we put the data into our calculator. So in L1, remember, I'm always going to put my input values in L1. I'm going to put my output values in L2. Okay, so I've got those values entered in, and then I'm going to look at, well, first of all, before I look at a scatter plot, I want to look at my graph. Now, when I look at the data I have here, my x values go from 0 to 0.5. And my y values go from 1.38 to 5.38. So in order for me to be able to see those values, I need to make sure that I have them framed properly. And that's what I want. That's why I'm going to change my window settings. Now, if I don't do that, and I make it -10, whoopsie, -10, 10, -10, 10, which is the default. Oopsie. And then I look at the actual graph, it looks kind of small. And remember, I want to be able to see that parabolic shape. So I'm going to actually adjust my window settings. Remember, as I've told you before, I like my minimums to be 0, because that way I can see the x and y axis, kind of like they've got here, but I like this to be 0. Okay? And then I want my max. When I look at my max, I don't ever go past 1. Okay? So I'm going to make my max 1. And my y max, it looks like I go up to 5.38. So I'm just going to go ahead and make it 6. Now when I look at the graph, I can very clearly see, hold on a second, let me fix that. I can very clearly see the pattern of my quadratic. And that looks quadratic, okay? So if it looks, I mean, this to me personally, this seems like a very pronounced curve. So when they ask me, does this look quadratic, this data appears quadratic to me. Okay, so when I look at the data, when I kind of just look at what I've got plotted, it looks kind of like that. Okay, now if it was linear, it would be more straight, but we can kind of see how it looks like it's going up, and then it starts to go up faster and faster. That's how you know you've got a quadratic graph. So this looks more quadratic to me because of the shape, okay? A linear would look more like, it might, you'd have points, but they'd all kind of be going in the same direction. And if you drew a line through them, you could kind of draw a straight line. I could draw a straight line here, but there's like a billion straight lines I could draw because the line is getting steeper and steeper, okay? So now that I've done that, they want me to graph y equals x squared over the scatter plot. So what we're doing here is we are looking at the graph, and we're trying to figure out what changes how we need to transform the quadratic function. So this is y equals x squared, the line here. Does it look right? I don't think it does. Okay, I don't think this looks right. It looks like it's been squished. So it looks squished, which tells me it looks like it's too horizontally compressed. So I'm going to say no. It's too horizontally compressed. Okay, it's too horizontally compressed. Okay, now they want me to say and it's also shifted too far down. Okay, so now they want me to pick a value for k. So I'm just going to go in. Remember, k is what I add or subtract. So let's just add 6. Let's add 5. Why not? When I look at the graph, whoopsie. That's way too high. Where does this look like it goes? Looks like it's about like 1.4. Let's make it 1.4. Oh, that's 14. Oopsie, 1.4. Okay, that looks really good. That looks like it's going right about through that point. So right now, 1.4 is what we picked for K, and we're talking about why we picked that point. We chose that point because it looks like it's lined up with the y-intercept of the graph. Okay. Now, they want me to start messing with values for A. So, do I need a value for A that's bigger than 1 or smaller than 1? Or, or between 0 and 1? Answer that question now. And why? Okay, I need a number that's bigger than 1 because this is too flat, which means I need to stretch it up to make it taller. Remember Mike TV? When they put him in the taffy puller, they stretched him and he got tall and skinny. I need this to be skinnier, so I got to stretch it taller, which means I need a number bigger than 1. So I think I need a number a lot bigger than 1. So I'm going to hit second delete to insert. I'm going to say, let's start with 5x. Okay, not even close. All right, let's take it up another notch. Let's do 15x. That looks pretty good, but it looks like, let's try 16. It looks like if I go just a little bit closer, let's try 16x. Okay, that looks really good. That looks like it's going right through those points. So the data, the equation that I found by messing around was y equals 16x squared plus 1.4. Okay, so now, and this is what they're usually going to do. They're going to ask me to find an equation and then use that equation. Okay, so I want to use it to determine the distance from the motion when the distance was about 7 feet. So I need distance to equal 7 feet. So let's look up here. Which one is distance and which one is time? Well, x is time, y is distance. So I need a y value of 7 feet. Okay, so I'm going to look at my table. Because remember, now that I've got a line of best fit, I'm not using these values that I have in stat. I'm not using these values anymore. I'm using these values that my equation is generating for me. Okay, so I have already changed my window settings. Hang on, okay. Hang on a second. I've already changed my table settings. Hold on a second. I've already changed my table settings. I had made them 0 and 1, but when I did that, like if you look, 7 is over here somewhere in the middle. And all the values in the table here are going up by 0.1. So I changed my settings. Remember, I don't have a setting that'll let me pick an x, an x value. But if you wanted to, you could have it go to second window and have it ask you. What I'm going to do is, since all of the values in this table are going up by 1/10, I'm going to make my table go up by 1/10. I'm going to have it go ahead and start at 0. Now when I look at the table, I can see it's going up by 1/10, and there, I see a value right there, and I could get closer, but 0.6 is good enough for me. So I think that after 0.6 seconds, that's when it's at about 7 feet. Now there's another value. Remember, if I went the other direction, I would find another one at negative 0.6. But does that make sense? No, because I don't go back in time. Okay? So I wouldn't use the negative side because the real world happens over here in quadrant 1. I'm not going to mess around with quadrant 2 because quadrant 2 doesn't make sense for the real world because we don't do time travel. Okay? So it says, list a few range values that will be unreasonable for this situation. So let's think about this, okay? So it says a book was dropped under a motion detector. The following data was collected. And I'm not going to lie to you, I'm not exactly positive about what a motion sensor is, but the distance from the motion center of 5.38 and how much time it took for this motion sensor to work. If I look at that, what kind of values make sense for that? How far away do you think this motion sensor is going to be sensitive? The motion sensors that I've seen have been the ones where, like, you drop something in front of them and you see how long it takes to hit the ground. So that's what I see. So I'm thinking there's a couple of answers. I mean, it'd have to be something like, so maybe if you were on a one-story building, like, it'd have to be less than 9 feet. right? Because our ceilings in here are about 9, 10 feet tall. Maybe if you were dropping it from the balcony, maybe you could say less than 16 feet or less than 20 feet. But again, it depends on how sensitive the device is. But if we're looking at something, I mean, if I'm looking over here and the distance from the motion sensor, if I look at these values, I mean, range values are my Y values. Once I get out here in the 20s, it doesn't make sense anymore. It's not very logical in terms of, you know, like how tall does the building have to be for me to be on it for it to be able to see these things, okay? So that's what we're doing when they ask us. Most of the time, what you're going to see on your test and what you're going to see on tonight's homework is that they want you to tell them how you need to change an equation, okay? So let's take a look at these problems. These are the kind of problems that you're going to see. They're going to say, okay, here is some data, okay? These are some dots, okay? If we take these dots, what do I have to do to these? What do I have to do to this function, the parent function, to make it fit these dots? Well, the first thing I need to do, this one's telling me to write an equation, but I can tell by looking at the equations they give me what I need to do, which one matches. So first of all, the first thing I see is that it's shifted, that I need to shift it down. Well, to shift down, I need to subtract k. I need a negative k, okay? I also see that this one looks wider than this one, okay? So I need to make it wider, which means I need to reduce my a value. So I need to make it a fraction. Because remember, we don't do horizontal stretches and compressions. We only stretch vertically. So if I want to make it shorter and fatter, I have to like the press, like the hydraulic press. When I squish the Legos, they get short and fat. So if I want it to get wider, I have to compress it vertically. Okay. So let's look at this next one. When I look at this one, I see two, maybe three changes, okay? The first change I see is it needs to be shifted right. So I see a shift right. I see a shift up. Okay, and then it looks a little narrower. It looks like I need to make it narrower. And again, I'm always moving the parent function onto the dots. I'm trying to make this graph look like the dots. I'm not trying to make the dots look like the parent function. I'm trying to make the parent function look like the dots. Okay, so to shift right, that's going to be an x plus or minus. Which one am I going to do to shift right? Well, shifting right looks like I'm adding, which means I'm actually going to be subtracting an h value. To shift up, I'm going to be adding a k value. And to make it narrower, I'm going to have an a greater than 1. Okay? So if I know to do this, then I can just look at the equations and see which one has those things. Okay? So I would look for an x that's subtracting h, an x that's adding to k, an equation where they're subtracting h, adding k, and your a is greater than 1. Okay? I want you to try number 10. I'm going to tell you right now, I basically see 3 changes. So I want you to see if you can tell me which 3 changes you can see. Okay, I see a reflection. Okay, I see a shift left, and I see a shift up. And again, I'm looking at what's happening to the vertex here. It's shifted up and it's shifted left, and then the whole parabola was flipped over. Okay, so to reflect, what do I have to do? Take a moment and answer that question. Okay, to reflect, I have to flip the sign on my a value. Okay, if I want to shift left, take a moment and tell me what I have to do to h or k. Okay, if I want to shift left, shifting left looks like it's going to be subtracting h, but really it means I'm going to add h. So I should have x plus h, not x minus h. And if I shift up, what do I have to do? Okay, to shift up, I have to add to my k value. If I was shifting down, I'd be subtracting my k value like this one. Okay? So really quick, the next thing I'm going to do, and actually I'm not going to show you with this one, we'll do these two practice problems in class, but I can, just like before, I can use the calculator to find, the exact same practice that we did. Remember when we did the line of best fit and we did stat calc 4? Well, if I go to stat calc, I see line 4 is linear regression. Well, hey, take a look at that. Number 5 is quadratic regression. So I can do stat calc 5. And then I hit enter a whole bunch of times. And I see, now this is interesting, 2e to the negative 2. Now the equation that I get from quad reg is not going to be in vertex form, okay? So we're going to be a little bit more focused on that later, but we are going to do some of this tomorrow. So if I was to write this, I mean there's barely even anything there, but I would probably write y equals, for this one, y equals 16x squared, because it's a is in front of the x squared, b is in front of the x, and c is by itself. Well, 2 times 10 to the negative 12, that's scientific notation. 2 times 10 to the negative 12 is basically a number so small I'm not even going to bother writing it. And then c is 1.38, so I'm going to say plus 1.38. And honestly, if you look at these two, they're pretty darn close to each other. Okay, I feel pretty good about the equation that I got. It matches this one pretty well. Okay, we're going to practice this some more tomorrow. But again, the thing to keep in mind, look at, whoopsie. The equation that we have here, ax squared plus bx plus c, that is not in vertex form. That is in standard form, and we haven't really talked about that too much. We're going to start talking about that in the next unit. So tomorrow we're going to actually, in class, we're going to do these two as practice, and then you're going to have some station practice to actually practice doing a whole bunch of quadratic equations with your partner. All right? Have a good day. I will see y'all tomorrow. Oh.